The next reaction for the chapter is an acid-base reaction, and this only works for our phenols, right? So primary, secondary, tertiary alcohols don't do this. They are not weakly acidic like the phenol is weakly acidic. So if I have a phenol, which I have up here, it can react with a base, right? Just like any other acid-base reaction. And we've done this before, so it should be somewhat familiar, right? All I'm going to do is I'm going to take the hydrogen and a hydroxyl group and turn it into a water, right? I guess I should have called that a hydroxide. But the hydrogen and hydroxide make a water, and then I'm going to have a salt product, which, in the past we would have written it differently. But here, we're going to actually draw out the structure of this salt, right? I have this phenyl minus a hydrogen, so there should actually be a negative charge on this oxygen because it's going to have an extra pair of electrons. And then that oxygen is going to be attracted to the sodium from that sodium hydroxide to make my salt. Now, since we are talking about phenols and things like that, this product is actually something you're going to be able to name, and you should name it correctly. This is going to be called a sodium phenoxide, right? So I could put other things on that phenyl group, right? I could have like a fluorine or a chlorine or a branch of any kind, and it would still do the same things. But then it gets a little bit too complicated, the name and everything else. So usually the curveball that I'll throw you for this example is just a reaction with a different base that will balance differently, right? So what I would do is I would react it with a calcium hydroxide instead, right? If I have a calcium hydroxide with my phenyl, I'm still going to make a water. But since there are two hydroxides, I should actually make two waters, which means I'm going to need two of my phenols for this reaction to work. So I can have two hydrogens to make those two waters when it's all said and done. So you have to balance it appropriately. Right? Now, again, I'm going to draw out the structure of my salt over here. I might tilt it a little bit so I can fit it. So I'm still going to have that phenoxide, and I'm still going to have a calcium, but that calcium has a +2 charge, which means I'm actually going to need two of these guys to balance with it, right? So you can either literally draw two of those, or you can just put parentheses around it and say that there are two for me, right? But that's the curveball. That's what it ends up looking like. So this now would have a new name. It's a calcium phenoxide, not a sodium phenoxide, but I don't think I need to write that. I think you could probably figure that out. You should probably write it in your notes. So if you have a phenyl, it can react with a base to do the same kinds of acid-base reactions we did before, right? And usually if I'm going to throw a curveball, it's going to be with that balancing issue, right? So making sure you understand that you make 2 waters or 3 waters or whatever, and you balance it appropriately so you have enough negatives to balance out that positive. So that should be it for the acid-base reactions. Oh, just the last thing. There is no catalyst for this, but I don't need a catalyst for this, right? Those two things automatically react together. When you have an acid and a base, they just do their thing, right? So I don't need a catalyst for this reaction. So if you notice that there's a missing catalyst, don't tell me no reaction. There's definitely a reaction here. So don't forget your water products, balance it appropriately, and give me a name.